Wisconsin, often seen as a land of dairy farms, rolling hills, and pristine lakes, has recently revealed a hidden, far more mysterious side. Beneath the pastoral calm of its forests and farmland, scientists in 2025 have uncovered a startling array of anomalies: ancient underground structures, unexplained seismic shifts, and signs of deep earth processes never before recorded in the region. In this video, we're diving into 10 shocking discoveries that are changing everything we thought we knew about Wisconsin's geological and archaeological past. From hidden lava tubes and glacial relics to ancient tools buried beneath the Ice Age moraine, this is Wisconsin as you've never seen it.
Every once in a while, research and advancement of knowledge at the University of Wisconsin can leave one in awe. It has again this week with the announcement of the UW-led discovery of fossils being described as a new species of human.
So, hit that like button, subscribe for more eye-opening Earth stories, and let's journey into the untold depths of the Badger State. A hidden lava tube network found beneath the Baraboo Hills. In March 2025, a team from the Wisconsin Geological Survey, using ground-penetrating radar, stumbled upon a network of lava tubes buried deep beneath the Baraboo Range. Though Wisconsin is not known for modern volcanic activity, these tubes may date back over 1 billion years, remnants of a Precambrian rift system that once tried to split the North American continent apart. These tubes, formed by flowing lava that hollowed out subterranean channels, are among the oldest of their kind ever detected in this part of the world. The structures are massive, some exceeding 10 meters in width and stretching for hundreds of meters underground. Inside the tubes, surveyors discovered walls lined with olivine-rich basalt, volcanic glass, and vesicles that suggest violent degassing events. Samples collected from within the tunnels have revealed a geochemical profile distinct from modern Midwestern geology, more in line with ancient continental rifting seen in places like the Mid-Continent Rift of northern Minnesota. Adding to the intrigue, some of the lava tubes appear to intersect older fault lines and crystalline basement rock, implying that the region may have been tectonically and volcanically active for far longer than previously believed. These intersections are now a primary target for additional deep core drilling, which may help reconstruct the full volcanic timeline of the Baraboo Hills. What shocked researchers most were faint magnetic anomalies recorded around the largest lava tubes, raising speculation about remnant magnetization from ancient eruptions. This find could provide insight into how early Earth's magnetic field interacted with volcanic processes during the Precambrian. Could these tunnels hint at ancient volcanic eruptions that predate Wisconsin's glacial history? Scientists now believe they might be uncovering the remnants of a billion-year-old volcanic underworld, one that still holds untold secrets beneath the rolling hills. Sudden microquake swarm shakes the Driftless area. Normally geologically quiet, the Driftless area near La Crosse experienced over 40 microquakes in April 2025. Seismologists were stunned. The region lacks major faults, yet the quakes occurred along a newly identified subsurface fracture zone stretching approximately 18 kilometers underground. Initial tremors were so faint they were only picked up by a new network of broadband seismometers installed as part of a groundwater study. But by the second week of April, residents in small towns like Viroqua and Westby reported feeling light rumbling, prompting local authorities to consult geological experts. The USGS dispatched a mobile response team to map the epicenters. Their data confirmed a pattern of stress release at depths of 3 to 7 kilometers, too deep to be caused by fracking or surface-level construction. The leading theory suggests that groundwater infiltration into older Cambrian and Ordovician sandstone layers may be lubricating a dormant fault system, which is now slowly creeping. Even more compelling, 2 shallow wells in the area began releasing hydrogen sulfide, an unusual byproduct of pressure shifts in sulfur-rich rock beds. This chemical signal, combined with the microseismic activity, has geophysicists concerned that deeper crustal processes may be reawakening beneath the driftless area. Some researchers are comparing the activity to similar low-magnitude swarms observed in central Oklahoma before larger quakes emerged. Could Wisconsin be at the start of a similar sequence? The region's unique, unglaciated topography could conceal far more subsurface complexity than previously assumed. Could this be the start of a new seismic era for the Midwest? The driftless area may soon go from being a quiet geological footnote to a central mystery in America's evolving tectonic landscape. Ancient copper tools found near Lake Superior's south shore. While excavating a site near Ashland, archaeologists uncovered dozens of copper tools and spear tips buried in glacial till. Carbon dating of surrounding charcoal suggests human activity over 6,000 years ago, placing it firmly within the old copper complex, a known prehistoric cultural tradition that mined and worked native copper across the Lake Superior region. But here's the twist. Several of the tools showed signs of intentional alloying. Copper, mixed with trace amounts of tin and arsenic. This is highly unusual, as alloyed copper typically appears in Bronze Age Eurasian contexts, not in North American prehistory. Metallurgical analysis using SEM-EDS scanning electron microscopy revealed uniform grain structure and controlled inclusions, suggesting deliberate smelting or mixing practices rather than random geological contamination. The discovery has set off a flurry of debate among archaeologists and anthropologists. Could this be evidence of a previously undocumented indigenous innovation in metallurgy, one that developed independently and briefly flourished before being lost to history? Or is it possible that long-distance exchange, perhaps even transatlantic contact with Bronze Age seafarers, brought alloying techniques across the ocean thousands of years before Columbus? Adding to the mystery, the tools were found alongside polished stone hammers, bone awls, and unusual ochre-stained pottery shards, some marked with incised patterns not previously cataloged in the region. Similar motifs have been found in Neolithic sites in Western Europe, though definitive links are still speculative. If validated through further excavation and peer-reviewed analysis, this could rewrite major chapters in both indigenous North American history and global prehistory. Could this be evidence of early transatlantic contact or a lost indigenous metallurgy tradition that once burned brightly on the shores of Lake Superior before vanishing into legend? Mysterious glacial caves open up in central Wisconsin. In early 2025, melting permafrost layers in Marathon County exposed deep, ice-lined caves beneath the ground, caves that have likely been sealed since the end of the last ice age. What began as a routine soil stability survey turned into a groundbreaking discovery when researchers uncovered a collapsed sinkhole that opened into a hidden glacial cave system. The temperature inside these ice-sealed chambers remains below freezing year-round, effectively cryopreserving their contents for millennia. Inside, researchers found remarkably preserved animal bones, including those of an extinct Pleistocene horse and a partially intact mastodon tusk, as well as plant spores, fungal traces, and ancient pollen granules embedded in frozen sediment layers. Preliminary radiocarbon dating suggests that some of the organic material dates back over 15,000 years, providing a direct biological snapshot of life just before the last Great Glacial Retreat. Teams from the University of Wisconsin and the Smithsonian Institution are now working together to extract and sequence DNA from these remains, which could offer insights into species adaptation and extinction during rapid climate shifts. Even more intriguing is the discovery of microbial colonies clinging to the walls of the cave ice, organisms that appear to be metabolically active despite the extreme cold. These extremophiles are being studied not only for their potential evolutionary significance, but also for applications in cryogenics and space science, as their survival strategies may mimic life forms that could exist on Mars or Europa. Some believe these caves may serve as genetic time capsules, holding biological evidence of pre-glacial ecosystems, and possibly harboring microbial or multicellular life forms that disappeared from the surface long ago. Could they also harbor extinct species, frozen in time, waiting to be rediscovered by science? Lake Winnebago's cracking lakebed raises alarm. In June 2025, sonar surveys of Lake Winnebago revealed long, linear cracks across the lakebed, some stretching over 3 kilometers. These fissures were discovered during a routine hydrographic survey conducted by the Wisconsin Department of Natural Resources. Sonar readings showed sharply defined edges and vertical displacements of nearly 1.2 meters in certain locations, unprecedented in a lake of this size and geological character. Divers dispatched to investigate found methane bubbles steadily rising through the cracks, hinting at subsurface gas pockets forming beneath sedimentary layers. Water samples taken at various depths revealed elevated levels of dissolved methane and sulfates, which could indicate microbial decomposition of organic matter deep within the lakebed. What's more alarming is that the gas concentrations are highest near populated shoreline areas, raising concerns about both water quality and explosion risk. Geologists now believe that the combination of warming water temperatures, fluctuating lake levels, and historical agricultural runoff may be softening and destabilizing the lake's deep clay and marl layers. Sediment cores retrieved from the site show signs of progressive delamination, thin sheets of sediment separating under pressure, indicating a creeping failure mechanism. This sediment instability could eventually trigger underwater landslides, capable of generating small tsunami-like waves and reshaping the lake's bathymetry. Computer models predict that a full-scale sediment slump could displace enough water to threaten docks, marinas, and shoreline infrastructure, especially during periods of high seasonal water levels. Local officials are now considering early warning sensors and methane release valves at high-risk zones. Meanwhile, geotechnical engineers are urging a reassessment of construction standards around the lake. Could the lake's very foundation be shifting beneath thousands of residents' feet? With evidence mounting, what was once a serene recreational hotspot may now be under geological surveillance for the foreseeable future. Magnetic anomaly discovered beneath the Chequamegon forest. In July 2025, University of Wisconsin geophysicists detected a strange magnetic field distortion while conducting aerial surveys above the Chequamegon-Nicolet National Forest. What first appeared to be a minor blip on the magnetometer quickly turned into one of the most significant geophysical anomalies ever recorded in the state. The anomaly spans over 15 square kilometers and is centered on a deep, dome-shaped rock formation buried beneath hundreds of meters of glacial till. Core samples extracted from test boreholes revealed a dense, magnetite-rich ultramafic intrusion with unusually high concentrations of nickel, cobalt, and rare earth elements, raising both scientific curiosity and commercial interest. Even more puzzling, nearby GPS units, aviation compasses, and drones began to malfunction within the perimeter of the anomaly. Pilots reported temporary loss of directional instruments, and multiple research UAVs veered off course or failed to maintain altitude. Despite clear weather conditions, the disturbance appears to generate short-lived magnetic pulses, which some researchers suggest could be due to piezomagnetic effects caused by tectonic stress on iron-rich rocks. Some scientists believe this could be the remnant of a buried iron-rich asteroid that impacted the region during the late Precambrian era, creating a shallow magnetic dome. Others hypothesize that the source is a deeply buried volcanic plug left behind by a long-extinct hotspot that once penetrated Wisconsin's crust during ancient rifting events. The implications are wide-ranging. Mineral exploration firms are now requesting survey access to assess the site's economic potential, while the FAA is investigating whether the anomaly could affect flight safety along local air corridors. Could this magnetic hotspot alter aviation and communications across northern Wisconsin? As exploration continues, the forest may soon reveal whether its secrets are terrestrial or from beyond the stars. Submerged stone structures found in Lake Michigan, off Door County. Divers surveying a submerged ridge off the Door Peninsula found something shocking: a series of carefully arranged boulders forming straight lines and rectangular enclosures. Sonar and LiDAR mapping, conducted from both boat-mounted and drone-based platforms, revealed not just a single line of stones, but a grid-like arrangement extending over 400 meters across the lakebed. The precision of the placement, particularly the 90-degree angles and equidistant spacing, strongly suggests intentional design rather than random glacial deposition. Archaeologists believe these structures may have been built during a brief period when water levels in the Lake Michigan basin were significantly lower, exposing what is now lakebed as habitable land. Geological dating of surrounding sediment layers suggests the formations are over 9,000 years old, placing them within the early Holocene, a time when Paleo-Indian cultures are known to have roamed the Great Lakes region. Some experts think the site could have served as a sophisticated hunting drive, designed to funnel herds of caribou or elk into a kill zone. Others propose it may have held ceremonial or astronomical significance. Intriguingly, certain stone alignments appear to point toward solstice sunrise and sunset positions, though further study is needed to confirm this theory. Underwater archaeologists from several institutions, including NOAA and the University of Wisconsin-Milwaukee, are now mapping the area in ultra-high resolution and deploying ROVs to recover any nearby artifacts. Stone tools, bone fragments, or charcoal deposits could provide invaluable evidence of human activity on the site. If confirmed, this would make it one of the oldest known underwater cultural sites in North America and potentially rewrite our understanding of early life around the Great Lakes. How many more Ice Age secrets lie beneath the Great Lakes? The answer may lie just beneath the waves, hidden in plain sight. Heat signatures detected under Wisconsin dells. Thermal imaging drones scanning the Wisconsin dells for geothermal studies detected unexpected heat emissions from shallow underground zones. At first, geologists assumed the anomalies were linked to buried utility infrastructure or natural gas lines, but follow-up ground surveys and deep thermal gradient drilling revealed something far more intriguing: sustained subsurface temperatures up to 15 degrees Celsius, higher than the regional average in specific sandstone and dolomite layers. Deeper scans revealed consistent geothermal gradients emerging from fractured bedrock associated with the ancient Cambrian sandstone formations that shaped the dells' spectacular gorges and bluffs. Rock cores extracted from test boreholes showed hydrothermal alteration, evidence of superheated fluids interacting with rock layers over geologic time. Traces of silica sinter and dissolved mineral bands further suggest the area once hosted active hot springs. This has sparked speculation that an ancient hydrothermal system lies dormant beneath the region. Some geologists now theorize that the Wisconsin dells may have been a geologically active area during the late Paleozoic era, and that volcanic or tectonic processes may have left behind deep reservoirs of heat. The fractured strata in the area, compounded by glacial erosion, may be allowing geothermal energy to rise more efficiently than in surrounding regions. Environmental scientists and renewable energy researchers are now conducting feasibility studies to evaluate the site's potential for low to medium enthalpy geothermal energy development. If viable, the Dells could one day power surrounding communities or even feed into the grid. Could Wisconsin become a hotspot for geothermal energy? The very rock formations that carved the Dells into a tourist destination may now position it as a frontier of sustainable power, hidden just beneath the surface. Fossilized forest, unearthed in northern Wisconsin. In Iron County, a road construction crew uncovered a perfectly preserved fossil forest beneath a layer of glacial clay. The discovery came during routine excavation for a highway expansion project. As workers cleared away layers of sediment, they exposed upright tree stumps, many still in their original growth positions. The surrounding clay had protected these ancient remains from erosion and decay, preserving not only the trunks, but also root systems and occasional impressions of ferns and seed ferns. The trees are believed to date back over 300 million years to the Carboniferous period, a time when Wisconsin was part of a sprawling equatorial swamp, teeming with primitive plants and massive insects. The fossilized forest consists mostly of lycopsids and calamites, giant, spore-producing trees that once dominated Earth's coal-forming wetlands. Some trunks measure nearly a meter in diameter, with bark textures still visible in the surrounding clay mold. Paleobotanists are calling this one of the best preserved fossil forests ever found in the Midwest. Excavations revealed not just individual trees, but an entire paleo ecosystem frozen in time, complete with fossilized soil layers, root casts, and plant debris mats. Analysis of spores and charcoal fragments also suggests the area experienced periodic wildfires, followed by rapid sedimentation, likely the result of flooding from nearby ancient rivers. This exceptional preservation is allowing scientists to reconstruct the exact conditions of Carboniferous ecosystems, including plant diversity, growth patterns, and climate dynamics. University teams are now scanning the site using 3D photogrammetry to digitally preserve it for future research. Could this reveal what ancient Wisconsin looked like when it was a vast tropical swamp? With new evidence emerging from every dig, the answer is a resounding yes. And this buried forest may hold the key to understanding North America's deep-time ecological history. The Great Moraine Riddle, an unnatural alignment. Satellite imagery from early 2025 has sparked a wave of debate among geologists and planetary scientists alike. Detailed elevation models of Wisconsin's terminal moraines revealed something unexpected: stretches of terrain forming unnaturally straight lines, intersecting at right angles and sweeping into near-perfect concentric arcs. These formations stand out sharply from the chaotic, random deposits typically left by retreating glaciers. While most glacial features resemble piles of unsorted debris, these moraine patterns exhibit symmetry and spacing that some researchers claim are statistically improbable to have formed purely by natural ice movement. Ground surveys confirm the linear ridges are composed of typical glacial material: clay, gravel, and boulders. But some layers show unusual compaction patterns and magnetically aligned particles. Most experts argue that the patterns result from unique ice dynamics during the Laurentide ice sheet's retreat, where constrained glacial lobes collided and stalled against natural bedrock features, creating pressure ridges and repeating shapes. However, a minority of researchers propose more controversial theories. One posits that the arcs may be remnants of a massive engineered landscape, ancient earthworks now deformed by glacial activity. Another even suggests the alignment may echo the concentric rebound waves of a long-eroded impact event, perhaps tied to a comet or asteroid striking thick glacial ice. Adding fuel to speculation, Recent ground-penetrating radar scans have revealed voids beneath several of the strait segments. Empty chambers or collapsed tunnels perhaps, but their origin remains unclear. No artifacts have yet been recovered, but further excavation is planned in 2026. Are these formations simply nature's geometry, shaped by ice, chance, and time? Or is there something more intentional buried beneath the till? With new data pouring in and interpretations diverging, Wisconsin's Moraine Riddle remains one of the Midwest's most compelling geological mysteries. So, what do you think about these 10 discoveries? Is Wisconsin really just rolling hills and cheese curds? Or is something far deeper, older, and stranger buried beneath the surface? Tell us in the comments, which finding shocked you most? The submerged stone ruins, the lava tubes, or the mysterious seismic swarm? Smash that like button, subscribe for more shocking earth science stories, and don't forget, the next big discovery could be right under your feet. Until next time, stay curious and keep exploring. World Map.